This is lesson 2-6a, how to find the possible rational zeros of a polynomial function. I've got two examples. The first example will give some background. The second example will be more like the problems you'll have in the textbook. All right, example 1. Find the zeros of 2x squared minus 5x minus 3. To find the zeros, we set it equal to 0, and we see if we can factor. This is factorable. It's going to be 2x plus 1 and x minus 3. Again, that's the minus 6x plus 1. Okay. Then to find the zeros, we chunk it up and set each chunk equal to 0. Okay. So one zero is negative 1 over 2. The other 0 is negative 3 over 1. I'm writing it in rational form so you can better see what's going on. One thing to note, these numerators are factors of the constant term. I'll make a note. Factors of the constant term. These denominators are factors of the lead coefficient. So in general, if a polynomial has rational zeros, it's going to be of the form a factor of a constant over a factor of a lead coefficient. And that's how we'll attack this next example. Let me just make a note of that. Factor of constant over factor of lead. Okay, example 2. Just make a list of all the possible rational zeros of 2x cubed plus 7x squared minus 4x plus 8. We don't have to actually find them, we just want to make a list, and later on we'll find techniques to find the actual zeros. Okay, I'm only concerned about the constant term and the lead coefficient. All right, so let's write the factors of the constant. So I'll just make a little list here. The factors of the constant, and it could be plus or minus, so I usually just write plus or minus once, and it's implied for the rest of the list. So factors of 8, 1, 2, 4, and 8. Again, 1 times 8 and 2 times 4. I usually put them in ascending order. Now for the lead. The factors are just simply 1 and 2. Okay, now for the possible, all I've got to do is take the quotients of the constants over the leads. And the way I remember it is constant over lead alphabetical, C over L. That helps me remember the template. Okay, so what I'm going to do is I'll use this. So I've got 1 over 1, which is just 1. 2 over 1, don't forget it's plus or minus, which is just 2. 4 over 1, which is just 4. And 8 over 1, which is just 8. So again, all I did was I took all of these factors over 1. Now I'm going to repeat the process, all of these factors over 2. Let me just rewrite this. 1, 2, 4, 8, 1, 2. I'll use a different color. So I've got 1 over 2. 2 over 2, which is 1, have it. 4 over 2, which is 2, have it. 8 over 2, which is 4, have it. So my list of possible rational zeros is plus or minus 1, 2, 4, 8, and 1/2. Again, there's 1, 2, 3, 4, 5. There's a total of 10. 5 positives and 5 negatives. And there you have it. Some background on how to find rational zeros and a way to make a list of all possible rational zeros of a polynomial function.